In this video, we're covering the hyperbola, and this is a type of graph that you can see on your screen here, where it has in one quadrant, it has a curve, and then in the opposite quadrant, it has a curve as well. These are known for having your variable, your x, on the bottom in the denominator. So again, the hyperbola, so this occurs when an equation in which the variable, which we usually say is x, it's not always, but usually it's x, is the denominator of the fraction. This forms a hyperbola when we graph it. So on your screen, there's two examples there. There's y equals 1 over x, y equals 1 over x plus 2. So when we go to graph these, our k value controls how close to the y and x axis the hyperbola is. So if we have a small value for k, the closer the hyperbola is going to be to the very middle, so the center there. Now the larger the k value, the further away it's going to be, and we'll see some of these examples later. But on your screen, you can see your base form, y equals 1 over x. Now, if your k is positive, you know it looks like this, where you've got it in quadrant 1 and quadrant 3. Now, the next thing we look at is if k is negative, and as you can see there, it's in quadrant 2 and quadrant 4. These also have something called an asymptote. Now, asymptotes are lines that the hyperbola approaches but never touches. So it'll get infinitely close to reaching this value, but never actually reach it. So for a general hyperbola, so y equals k over x, y equals 1 over x, the asymptotes are the x and y axis. So in our example on your screen, the red lines will get infinitely as close as possible to our black lines, but actually never touch them. Now, if you have something like y equals 1 over x minus 2, that shifts the asymptote, because you need to realize that on the bottom, you can't have a 0 in the denominator. You're not allowed to have 1 over 0. It doesn't exist. You'll get a math error in your calculator. Now, for this example, if I have 1 over x minus 2, we can actually have 0 this time. What we can't have is a 2. If I have 1 over 2 take away 2, well, 2 take away 2 is 0, so I have 0 on the bottom, and we're not allowed that. So the asymptote is whatever the x value is, well, sorry, the x value cannot be on the bottom. So in this example, x cannot be 2, so our asymptote is at x equals 2, and it's a straight line going up. Now on your screen we have some examples of hyperbolas, and we're going to try to match them with the equations. So in a similar way to how we did cubics and parabolas, we're going to take parts and then try to identify the appropriate hyperbola. So the first one is y equals negative 1 over x minus 1. So I already know it's a negative, so I know I'm looking at quadrants 2 and quadrant 4. And I know that on the bottom, if I look at x minus 1, I know x cannot be 1 because that'll get me 0. So I know that my x asymptote should be at x equals 1. Now, it's not going to be the first one because that looks like it's at 0. It's not going to be number 2 because it's also at 0. So we're stuck at either 3 or 4, but the asymptote for number 3 is at 1, so therefore it must be 3. The next one is y equals 1 over x, and I know that as a regular hyperbola, so that's going to match up with 1. The next thing we're looking at is y equals 3 over x. Now remember when I said that top value, the larger it gets, the further away it will go from our asymptotes, or the x or y axis. So which of these 4, number 2 is the furthest away? And I can tell that by comparing it with number 1. Now if you look at number 1 and number 2, both the same shape, but number 2 is much further away than number 1. Therefore, this is number 2. And lastly, this must be number 4, and if I look at the bottom, I'm not allowed to have negative 2 there, and it does look like my asymptote is at negative 2. So to make things a little bit easier, in blue on your screen there, you can actually see the asymptotes now, and it makes a little bit more sense of what I was trying to say. So for number 3, you can see that there's a blue vertical line at 1. And that made sense because if we go back over to our equation on the left, we had x minus 1 there, so we know x can't be 1. That's why there's an asymptote there. If we look at the last one, there's a vertical line at negative 2, and that makes sense with the equation because remember we said x can't be negative 2.